I think I don't think people know that we're having lab.
Oh, really?
They
Oh,
might think they might think lab is over because we're online.
uh, well, I've been trying to guide people through the online work, and nobody. I never. I said the labs would be online actually in class. So um, in any case, there's only one final project left, and then there's this so-called I guess you might say uh, homework, right? The homework 11, which is due on Thursday. Um, and if you had any questions about homework 11, I would certainly answer them for you.
Oh, I'm good. Maybe just when is the project due?
Yeah, I got all the I got everything here. The final project in EE 346L is due on the 9th of December. So
Oh,
right now it's the 2nd. So thinking that's like a week, isn't it? Just a minute. Let me just check.
yeah, it is.
Yes, 1 week from today. And I can go over that with you if you think you might need a little help.
I probably will. Are you open to having like Zoom sessions?
Yeah, I'm having a Zoom session now,
Okay.
right?
Yeah.
And you're the only one here, so it's almost like it's like you've got personal one-on-one questions that I can answer for you.
Okay.
Um, and so, if that's the case, I'm perfectly happy to entertain your questions about the um, uh,
Okay. So the project. Uh, I came late to the last class when you were explaining it,
Oh,
but
all right. Well, let's go over it then. Again, you're the only one who's here, so we can certainly work on that. Let
okay.
me close out some of this other interesting and wonderful stuff about Ethernet. So this is a. Let me get to the project page opened so that we can go over it together, and I can answer your questions. Just a minute.
Okay.
Let's see. You should be able to see this. And we'll go to the course content, and then we'll go to the homeworks, I guess, or no, go to lab, touchtone synthesizer. So, have you had a chance to download the zip file yet?
No, not actually.
Why don't you give that a try while we're online?
Okay. Course content. So the the code for the project is in that zip file.
Mm-hmm. Yep, that is true. So this is the touchtone synthesizer, right? So we're getting frequencies across the top and frequencies across the side. And
Mm-hmm.
every time you hit a button, you get two frequencies at the same time. And those two
Oh,
frequencies are described right over in here. Here you can see each button. So if you hit a 6, for example, you get two frequencies, 770 and 1477.
okay. Yeah.
And then what I did was I used a decoder chip to show you how these things can be decoded in real time using hardware. Because you use a switch capacitor filter and a little counter after you square up the sine wave and make it into a square wave. And that's what you call a frequency counter. And frequency counter is actually a very nice way to analyze one frequency at a time. But to get one frequency, you needed a low pass filter and a high pass filter. And these would be the high frequencies right over here on the top. and these would be the low frequencies over here on the bottom. So once you got those things going, you're only counting square waves coming out of just one band at a time, because you can't press two numbers at once.
Yeah, you can. Okay, so I got the file.
Good. So now, after you unzip the file, you should be able to open up the INO file, and then you should get something similar to what we see here.
Yeah. But I don't have the other files. The only one I have is the DTMF generate and then the DTMF.
You don't have it?
I don't have the DAC.cpp and DAC.h.
Right, because I created those separately to try and encapsulate the complexity a little bit better. There's another sort of thing that you can look at, which may be of some help to you. If you want to, you can look at the, well, this code is probably similar to the code you've downloaded, and it should work with your DAC board. But the other code that you can look at is the code over here under embedded microcontrollers. If you go into course content, and then you take a look at books, you'll see one of the books is about music, audio projects with Arduino. So if you open that up, you get this. And then when you look at it, you should be able to find the 4921, which figures prominently under generating waveforms. And if you get into the index, we could zoom in, I guess. How does one zoom?
The plus.
Yeah, that's doing it. MCP 4921 should be in here. And if it's not, well, we'll just search. 4921, enter. And there it is. So there is his take on the 4921 DAC. And so now he gives you a different way in which to do the synthesis, which is kind of interesting. And he's using the same hardware you're using, same exact hardware. And so then when you take a look at the generate table, that's very similar to what I did, right? Because in the last class, I went into the DTMF CCP, and instead of typing in the wavetable by hand like they did before, I just went to my setup and I said to generate the wavetable. So I said wave generator, and then I said something like, well, there must be something in here for generating the wavetable. It's probably in the setup, I guess. I'm gonna find the setup. Oh, here it is. I should write a comment in here so people can find it. Generate sine wave. Wavetable. That's better. So that, you know, it says cosine, but you could just as well say sine over in here. Well, sine. And then if you compare what I did with what he did, it should be roughly equivalent. I simplified things because he's multiplying by 2, dividing by 128. And what did I do? Well, I said 2 over 128 is the same as 1 over 64, right? I mean, it's the same. So, and then he decided he was going to make his thing a full 12 bits. And so he went out to 4096. And so what I did was I said, look, I'm doing this in 8 bits because that's all I needed. But you could have done it with 12 bits. That would have been all right, I guess. And then here's an 80 write. Now, the 80 write on this one, this is a full-blown 16-bit input on the 80 write. So if you look at his code here, in principle, it's very similar to the DAC write code here, with a difference. And the difference is, whoops, what happened here? Oh, it all went on one line? Oh, that stinks. Can I undo that? Why does it all go on one line? That's got to be some kind of a strange problem. Yeah, look what it does. It writes it all over the place. That's no good.
You copied from, this is the code from the book.
I did.
Okay.
And so that's no good. It's got to be fixed. I don't know what to tell you. We got to fix it. So search for // go back, put in a new line, go forward, repeat. It's just so bizarre that it should do that. And then this doesn't look at all like the code that he started with, does it? I mean, it's so weird. You can't cut and paste out of these things, huh?
Yeah.
I mean, why not? Well, I guess it's up to somebody who wants to type this in, I suppose. Or maybe you can save the page as, can you do text? I don't know if that's going to work. That doesn't look like it's correct at all.
I think it took the whole page.
Yeah, it looks like it tried to save it as a an HTML document of some sort. I don't know. It's a very strange way to deal with these things. Maybe there's a way to alternate forms. Can I get it as HTML PDF? It's like I want to save it as a PDF. How do you do that? You suppose that oh, it did it. It did it. Oh, look. So now I can actually open it with Adobe Reader if I want to. And now I can do a proper search for 4921. And here is the actual code. Let's zoom in.
Yeah.
And there it is. So now maybe we can cut and paste or copy and paste. So weird, right?
Mhm.
Copy. That looks better.
Yeah, it does.
So apparently you can copy and paste from Acrobat, but you can't copy and paste from Blackboard. I don't know. Go figure it. So now that's correct. Now it's correct. So now all I have to do is say DAC : and then I suppose AD right wouldn't be correct. How about we just call it DAC right and overload it with a
Oh,
there. DAC.
perfect.
Yes, sir.
When you're done, yeah, could you, because I can't copy and paste it as well. So like, could you just send me the code?
Well, I think you can copy and paste, can't you?
No, like it's not letting me copy and paste from the book itself.
Are you able to download it in PDF?
Uh, well, I don't have Adobe Reader. Like,
I think it's free. You can download it.
okay,
What are you on? Are you on a Mac?
yeah,
Yeah, you can get it for the Mac. But in any case, I would comment out all of the port stuff and leave in the general digital right stuff.
it doesn't let me copy and paste.
It doesn't let you copy and paste?
Yeah,
Well, it needs to be modified anyway, and it's not that much code. It should be possible to make a change if you want to. Anyway, I don't know that you want to have 16-bit DAC output. I think that the byte-based DAC output should be sufficient. And this is untested code, so we haven't worked it yet.
okay.
Right? So at some level, there's going to be like these things, AD latch, CS80C bar. That's got to be defined in here somewhere, like over in here, for example. And so that too will have to be copied, or else it won't compile, I should think. And then even if I do that, it may or may not like it. It doesn't have a prototype. So you still need this to be written with a prototype that takes in. He says send to the A to D, but it's not an A to D, it's a DAC, right? So that is probably going to be replaced by this. Then you've overloaded the needs a semicolon. You overloaded the method. Right, so now it's got two data types. One is for 8 bits and the other is for 16. You see. And so what you would do is you would have to test it with a do you have the audio shield?
No, not actually.
You don't. Did you get one at the beginning of the semester?
Oh, we had to return it. I think Chris took mine back.
Chris took yours back? No. We needed it for the final.
Oh, is it the green board? Oh, yeah. I have it. I have it.
You have it?
Yeah.
Okay. Yeah, you shouldn't have taken it back. That's not good. Anyways, I've got one handy here, and what I can do is let me see if I can get this to. I'll just plug mine in. And then I'll plug in my my speaker.
Mhm.
So you can hear it's running now.
Oh,
And then what I would do is make sure that I've got the correct port, because I just plugged in a new Arduino.
okay.
And that's my Arduino right there.
Excuse me.
Gesundheit. So now let's see if I can upload it. And then let's see what happens here. And now it's broken. So there you have it. There's a compelling argument not to use that code. What do you suppose has happened? You think DAC write is actually being used here? I don't think so. Let's give it another name. We'll call it DAC write 2. Or maybe DAC write 16. That's a good name for it because it's a 16-bit DAC write. And then this one will be DAC write 16. I just want to make sure they're not being called inappropriately. And now we'll upload. And now it's broken. Oh, it's working. So apparently calling DAC write 16 did not work. Now that could be because I got to turn off this volume. So now we've got to go back and figure out where DTMF generate calls DAC write. And it's DTMF generate, so that's going to be over in here. And somewhere there's going to be a generate, there it is. And I think we'll find DAC write in here somewhere. And there it is. So now if I were to call this DAC write 16, I think you've got to make an int. Call it the sample equals output, and then shift it over by 8 bits to give you a 16-bit output. And now if you do DAC write 16, it should work, I hope. We'll have to see. Yay, it works. So that's uncomfortably fast. So what you would do to make DAC right 16 look the same as DAC right is you would change the keywords in the keywords file. So if you said show sketch folder, you see keywords.
Yeah.
Yeah, you want to make DAC right 16 into a keyword. And if I type in DAC right 16, it might not take it. No. See, you know what you gotta do? Is you gotta quit and then restart. Because it's not reading keywords until initialization phase.
Yeah.
Oh, it still didn't take it. Isn't that funny? Why wouldn't it take it? DAC right 16. Let's make sure we know where this is. Sketch, showing in sketch folder, and copy. Yeah, DAC right 16 is in there. That's very interesting. Why shouldn't it read it? I don't know. That should have worked, but for some reason it did not. That works. What is it about these two things that are different? Did I misspell DAC right? It looks right to me.
All right.
It looks right. I don't know what's going on here. That should have worked. Well, silly me. Didn't work. But life in the big city. Anyway, the 8-bit version works and is highlighted nicely. The 16-bit version, for whatever reason, does not highlight. But I'll call that a blemish. So let's see what else we need to know about this. So you've got an assignment here. What's the assignment? Let's take a look at the assignment. That's always educational. Your DAC requires amplified speakers, cannot directly drive the speakers. Have you tried running the code yet?
No, I don't have a speaker. So
Oh, you don't have a speaker.
yeah, until I get one, then
Yeah, you got to do something to amplify the code, or get a pair of iPod headphones or something. You definitely have to do that now because you only have a week now to go, and this was a 2-week project. And if you have to order speakers, it'll take days to get there, so you can't dawdle.
Okay.
if you wait till the last minute and say, "Oh, professor, I couldn't get speakers," then I'd be like, "Well, what happened to you all semester when you were trying to do these things?" It's like, not good. So after uploading your code, you have to reset your Arduino in order to get a sound to come out. I've noticed this. Actually, it doesn't happen anymore. I don't know why. Your submission will consist of a zip file with your code and an audio file or video file with the audio created by your program. If you cannot get things to run properly, please mention this in your submission so we do not spend too much time getting things to run, because I'm going to try and run your code. And then here's the backstory about DTMF. Sample code in the zip file. You will have to modify the code. 1, to play frequencies A, B, C, and D, which I have done. Right, so if you came in a little bit late, I think you'll see that I've added A, B, C, and D here. So that, that may be of some help.
Yeah.
And then I keep thinking maybe this is not the most efficient way to do these things, but I don't know. And then it says, make use of the DAC in your audio shield. You may like to use an 8-bit DAC method in your code, something along the lines of this, DAC write. So that is an 8-bit DAC method versus the 16-bit DAC method. So that's here, as well as the init. They're both here. Let's see. The rest is pretty self-explanatory, I think. Well, what do you think? You got any questions?
No, right now.
You're good?
Maybe
so we got to get you to start playing tones. Do you have any speakers built into the monitor of your Mac?
I mean, the Mac itself has its own speaker.
Has its own speakers. If you have a television, a little video display with speakers, oftentimes they have a little 3.5 millimeter jack on them. So I have, for example, an extra monitor in the house, which I use sometimes for computers, and that enables me to play audio because it's got speakers built in. There's another way to go on this. If you do 4921 again, and then you zoom in. Let's get this flashing thing done. So he generates his table in a separate subroutine. Here's his DAC write, although he says to send data to the A to D. So that doesn't make sense. I don't know why he wrote A to D. And then he shows you the actual output. That's kind of nice, actually. And when you do the touch tone thing, he has his own sort of coverage on touch tones. And so these frequencies pretty much match what I have, I think. This thing is flashing at me again. And so now here's what he's done here for the table. He actually figured out what the period is for each one of the frequencies. Then he figured out what the count would be in microseconds. So you can count how many zero crosses there'll be in 10 microseconds. And this will give you a sense of how to decode these square waves if you were to square them up with some sort of a comparator. And then he gives you, which I thought was kind of nice, a way to hook a speaker up to the output. But I say you're better off with a little amplifier. Don't try and wire that up. That's ridiculous. And then he goes on and on about DTMF tones. And then he does this thing here, which I thought was a nice, slick way to do things. Because now when you go and increment through each row and then each column, you get to a different tone number. Now he's calling these tone numbers the number of cycles per, the zero crossings per 10 microsecond increment, and he sets up a timer at 10 microseconds, which is fine, I guess. But the way I did it was a little bit differently because I wanted to be able to dispatch based not on the position of the character relative to the row or column, but just on terms of the absolute character itself. So that basically meant that I had to do a long dispatch, which is why there's the case statement. What this guy is doing, he's doing pulse code modulation to generate his tones. And that's really different than what we were doing by creating a wavetable. So that's a different approach. It's interesting. It's not what we're doing, but it's nice to be able to see that somebody else has got an approach on this that's a little bit different. Turns out I was doing a very similar sort of thing for my initial audio synthesizer. My board was using PCM as well, but I've decided to jettison that and move on to a DAC. And I think a 12-bit DAC is going to give you much nicer quality and is a far more straightforward way to program things. So that's that, such as it is. And, what you would do if you were going to use this approach, and I don't recommend it, but if you were going to, you would substitute the tone rows and the column rows with real frequencies. And so you would go back to his little matrix of frequencies, which is over in here, and you'd write those out along the columns, and then you'd write this out along the rows. And that would give you an ability to sequence through the different tones just by running a doubly nested for loop, which I don't particularly find all that good. So the comparison is, your doubly nested for loop versus the big dispatch using a switch. This switch is going to run fast, and it enables you to take large strings and iterate through them. So you can basically write any number you want to in this string, which is, I think, a feature. So if you write that and hit generate, it should generate a call to information. In theory. Oh, it's not working at all. Maybe I have to reset. Sometimes that happens. Yeah, there we go. So you can hear that. It's dialing information. Whenever I call up information, I ask for information about stuff, I'll say, and what is the 23rd digit of pi? And she says, I don't know that. And then I say, but isn't this information? So, yeah, this is what happens when wise guys call up information. So as it happens, this code could probably be made better, especially with regard to the timer code. I don't know about the dispatch code. The dispatch code's pretty good right now. The only thing I could think of that would make the dispatch code a little bit nicer would be, do we need this? Maybe, because he's got the row position and the column position. Yeah, I guess you need it. Or is that part of the wavetable? This timer stuff, I don't know. It's row position, column position stuff. Doesn't it compile without it? Does it work without it? Yeah, no, you don't need that. That's garbage. So there's that. What else? You know, sometimes I think it's better if you have a few extra subroutines, like a subroutine in here that says disable timer 1.
Mm.
That'd be a good subroutine. Set timer 1 to 10 kilohertz. That's probably a subroutine right there. But you know, you get carried away if you keep writing subroutines like that. And every time you write a new subroutine, you got to update the header.
Oh.
You know, that's not. I mean, even if you just said, I don't know, disable timer 1. Just call disable timer 1. Disable timer 1. Right, so then I do something like this. Void DTMF disable timer 1. Right, put that in there. Now that's legit, right? Except somewhere in the header, we'll probably have to call void disable timer 1, or else it won't compile. Did I? Oh, have to call DAC. Now what's his problem? Void disable timer 1 should be part of. Oh! I got this in the wrong place. That's not supposed to be in DAC. That's supposed to be in DTMF.h. Good thinking.
Mhm.
And so then if I'm DTMF not declared in scope. Oh, what do we just call disable timer 1? You don't need to qualify it. Huh. So you can see what I went through. But I guess once you get used to it, it'll happen a little bit faster. See if that works anymore. Yeah, so that worked. Despite how painful that was to watch. Sorry about that.
That's okay.
So now we've got a little subroutine that says disable timer 1, and we went into DTMH and put in a private disable timer 1. So that kind of contains the complexity involving disabling timer 1. Similarly, when you want to initialize the timers, you see this code here?
Mm-hmm.
I think this code looks just like that code. It's the same code. So we have duplicate code. So, init timers to 0 should probably be a subroutine to remove the duplicate code. So I would do something like this. Void DTMF init timers to 0. Right? And then take all of this and replace it with init timers to 0, because you don't want duplicate code running around in your program, because that's like a bad smell. And then init timers to 0 has to be part of the DTMF header. Looks like I've made a typo in here. And then I think you can do this. And so you can kind of see why that's better. Let's see if it works. So we're reusing some of the code instead of having duplicate code floating around. See if that works. So that's still working. Good deal. So duplicate code is a famous bad smell, and refactoring out common code into a subroutine like init timer 0 effectively uses this code both in here and also where we initialized the timers over here. And in fact, what you really want to do is you want to go into your keywords and put that in there too. Now the question of why that doesn't necessarily highlight remains open. I had thought, well, maybe if I quit and restart, it would highlight it, but for some reason, I don't know why it didn't. See how init timers didn't take? That's just weird, right? Why should that be? Why should that be? But anyway, that's the way it is. So for some reason, it's not, maybe my understanding of how keywords works is defective. That's possible. Must be. So what else can we refactor in here? I suppose this could be refactored, but there's no common code anywhere that I see. So moving it to a moving it into a function might not be of much benefit. I can't think of a better way to look up the row and column except by virtue of the switch statement. I don't think anything is going to be faster than a switch statement. And this is giving us the number of cycles. So that's actually okay, I think. What else? I guess that's it. That's what I got. What do you think?
Yeah,
Probably.
It's going to be difficult when I'm doing it. That's just the problem. So
Yeah, we've got to get you a some speakers. You've got to have speakers. Because otherwise, and how are you going to do this? You know what I mean? Does your computer have a microphone input?
I don't know.
What kind of computer do you have?
I just got the MacBook Pro.
MacBook Pro. Which year?
I think it's the 2020.
What year?
The 2020.
2020? You got a brand new one?
Yeah.
Is it the M1 processor?
Hmm.
You don't know?
No.
So it says here it has a 3.5 millimeter audio input. That should be compatible. So if you plug your output from your audio shield into the Mac, it should be able to amplify it and hear it. According to this, there's audio in. So from the point of view of the sound device, you got your choices of inputs, and one of them is line in. So in principle, I could take the output from this. No, let's try this. I'll plug it into my Mac right now.
Yeah.
Bear with me a minute.
Yes.
See, I don't have the same computer you have. I've got a Mac Mini, so now I've got to look it up.
No.
Mac Mini. I never used the audio input. I think it's 2012. I got an old one. It says, my Mac Mini does not have an audio input.
Oh.
Huh.
That's
Yeah,
fine. I'll figure it out. If anything, I could speak to Chris because he's helpful. So I'll ask him.
sure. You wanna shoot him an email?
I just texted him now. So
Yeah, you should be able to get some help
yeah.
from Chris. Do you need help with something?
If I do, I'll reach out to you through email. Is that okay?
Yeah, sure. Now here is the SD slot, and he says I've got an audio input here, but it's for microphones. I'm going to try and plug in the line output from my little dialer and see what happens. Wish me luck.
Look.
Let's see. All right, so now I've got audio going in, but I don't hear anything. So I think I have to select it in the system preferences, and that may take me offline. Let's just see what happens. Input, audio line in. Gee, I'm not hearing it. I wonder if I have to testing. Can you hear me? Oh yeah. I wonder if I have to do something with the mixer because I don't hear it, but I can see it. Right? Here it is, input level, and it's looking very loud. So I suppose this has something to do with Zoom. Does Zoom give me a chance to change my audio inputs? I don't see it.
Mhm.
What's this? Can you hear me now?
Yeah, I can see. I was hearing you also.
Oh, you were hearing the dial tone,
Yeah, but it was low.
but it was low, but you did hear it. Oh, that's
Yeah.
good. I didn't hear it. You know, the Zoom wasn't listening for some reason to that audio input. Maybe if I had started it, I don't want to quit and restart, but apparently it works. Let me unplug it now. So that's good. So now you can use your MacBook Pro. You can get the audio input. I guess you can listen to the audio input, and then you can play around with the dial tone system. So, anyways, um, you got any other questions for me?
No, Professor. Thank you.
Sure, I'm happy to help. I'm a little surprised nobody else is here, but I guess they didn't have any questions. Oh well, too bad. All right, so then I guess unless you have some more questions or unless I can help you with something else, I'm going to leave it at that. Is that all right?
Yeah, Professor.
All right, very good. Well, thanks again.
Thank you.
Have a
All right.
good day.
You too.
All right, bye bye.
All right.